Hi there, and welcome to this lesson on Pure Mathematics 2. And in this lesson, we're on Chapter 1, and we're looking at 1.4, the Remainder Theorem. Now, in the last lesson, we learned that if we put x equals a into a function, and we get 0 for the answer, so if f of a equals 0, what that means is that x minus a will be a factor of the function. Or another way of saying this is that if f of a equals 0, when we divide the function by x minus a, the remainder will be 0 because it's a factor. But what happens if the value of the function is not equal to 0 when we put x equals a into the function? Well, in general, when we divide f of x by x minus a, the remainder is the f of a. So if we put a into the function, x equals a into the function, whatever we get out for the answer, that is the remainder when we divide by x minus a. And this is called the remainder theorem. Okay, I think let's do an example just to see exactly what this means. So we'll find the remainder when we divide x cubed minus 5x squared plus 10x minus 6 by x minus 2. And we'll do it in two ways. So we'll do it by using algebraic division, the method we learned a couple of lessons ago, and then we'll do it using the remainder theorem. So using algebraic division means you'll have to write down the cubic and say it's equal to x minus 2 times by something. Work out what the something is, but this time you will get a remainder at the end. And then we'll work it out using the remainder theorem. And to work it out using the remainder theorem is very straightforward. All we have to do is put x equals 2 into this function, and whatever we get for the answer, that is the remainder when we divide by x minus 2. Okay, I'll let you have a go at seeing you can make sense of all of this by yourself first. So pause the video, see if you can work your way through this question, and then come back to me again as soon as you're ready. Okay, let's have a look at this. So first of all, if we divide the cubic by x minus 2 using algebraic division, then we need x times by something to get x cubed. Well, x times x squared is x cubed, so that makes the x cubed term correct. Now we look at the x squared term. We want minus 5x squared. At the moment, we've got minus 2x squared when we multiply these together. So we need another minus 3x squared. And to get that, we'll have minus 3x here, because minus 3x times by the x gives us minus 3x squared. Now the x squared term is right. So we look at the x's. We want plus 10x. Well, at the moment, we've got minus 2 times minus 3x. So at the moment, we've got plus 6x. We want 10x, so we need to add another 4x. The way we'll do that is by having plus 4 here, because plus 4 times by the x gives us plus 4x. So all of these terms are right, but now we do have to make sure that the constant works. If this is a perfect factor, then when we multiply these two numbers together, we always get that one. But that doesn't happen in this case. So we want to get minus 6. But if we do minus 2 times by 4, we get minus 8. So we've got 2 too many. That means we need to add 2, because if we add 2 to minus 8 plus 2, that will give us the minus 6. And it's this plus 2 here that is the remainder when we divide the cubic by x minus 2. So the answer would be, if I divide this by x minus 2, I will get a remainder of 2. Now that's quite long and complicated using algebraic division. What about if we choose to use the remainder theorem? It's a lot easier. All we have to do is put 2 into the function. So if we're dividing by x minus 2, then we find f of plus 2. Putting 2 into the function gives us 2 cubed minus 5 times 2 squared plus 10 times 2 minus 6. You can put all of that in the calculator. It simplifies to this, which simplifies to f of 2 equals plus 2, which is the answer we got before. Now that is the remainder theorem. That's what this gives you. So that means that the remainder, when I divide this cubic by x minus 2, is plus 2. And you can see how powerful the remainder theorem is, how quickly it gives you the answer that you want. Okay, example 2, same idea. This time we're only going to use the remainder theorem. We're not going to divide by the factor. So find the remainder when the quartic equation given there is divided by x plus 1. Now, if it's x plus 1 in the factor, it's minus 1 that we're going to have to put into the function. But that is all we have to do. So we put minus 1 into the function, whatever we get for the answer, that will be the remainder when we divide by x plus 1. Have a go at finishing this off yourself, pause the video, come back to me when you're ready. Okay, let's have a look. So if we put minus 1 into there, x equals minus 1, that'll give us minus 1 to the 4 plus minus 1 cubed plus 3 times minus 1 squared, minus 2 times minus 1 plus 1. All of that you could put into the calculator, making sure you're careful with brackets. Or if we do it the long way, it would give us that, which gives us 6 for the answer. And that means if I divide this quartic by x plus 1, I will get a remainder of 6. Now, what we've just been doing there is dividing a function by x minus a, and we've said that when we do that, the remainder is always f of a, what I get if I put a into the function. If we divide f of x by a more complicated factor, ax minus b, then same as we met in the last lesson, the remainder will be the value of the function if we put b over a into the function, x equals b over a. It's the value that makes this bracket equal to 0. Okay, bearing that in mind, see if you can do this question. Find the remainder when this cubic, 2x cubed minus x squared plus 2x minus 3, is divided by 2x minus 1, again using the remainder theorem. So all we need to do is put the right value into the function, and the value is b over a. So in this case, 1 divided by 2. Okay, have a go at doing that yourself. So pause the video, see if you can finish this off, and then come back to me when you're ready. Okay, let's have a look. So as we said, in this case, f of b over a is 1 over 2, which means we need to put x equals a half into the function. That gives us 2 times a half cubed minus a half squared plus 2 times a half take away 3, which would simplify to that, which gives us minus 2 for the answer. And again, that means that the remainder, when this cubic is divided by 2x minus 1, the remainder is minus 2. Okay, example 4, slightly different, but the same idea. We're told in the question that the remainder, when f of x equals 2x cubed plus ax squared minus 12 is divided by x plus 4, is 20. So we're told what the remainder is, but we have to work out what the value of a is. So what we know is, we know that f of minus 4, if we put minus 4 into the function, we will get 20 for the answer. Okay, bearing that in mind, see if you can work your way through this question by yourself and find the value of a. So have a go, pause the video, and come back to me when you're ready. Okay, let's have a look at this. So this time they've told us both what we're dividing by and what the remainder is when we divide by that. So what that means is if I put minus 4 into this function, that's what I get if I put minus 4 into the function. I know that this is going to equal 20 for the answer. But first of all, I just need to tidy up what I get when I put minus 4 into the function. So I'll get 2 times minus 4 cubed plus a times minus 4 squared minus 12. That simplifies to minus 128 plus 16a, take away 12. And that simplifies to minus 140 plus 16a. But we know that this must equal 20 because this is the remainder and we've been told that the remainder is 20. So therefore, minus 140 plus 16a has to equal 20. That gives us a simple linear equation in a which we solve, which gives us 16a is 160 and a equals 10. Okay, that gets us to the end of the lesson. If you've got the textbook, then turn to page 12 and have a go at exercise 1D. Thanks very much for listening and cheerio.